Poor cardiovascular health is at the root of the deadliest diseases in Western society, leading to strokes, chronic heart and lung diseases, and also has a strong link to mental health issues. In addition, poor cardiovascular health leads to a higher risk of infection and negative outcomes for infections such as COVID-19. Cardiovascular health is strongly impacted by a person's fat makeup and is often correlated to being overweight or obese. Currently, a person is identified as overweight or obese according to their body mass index, or BMI. BMI is, however, flawed since it only takes into account weight and height and doesn't take into account things such as body fat percentage, muscle mass, and fat distribution. For instance, we know that the fat stored in the midsection near the organs is a lot more dangerous than fat in the thighs, for instance. Limitations to the current measuring equipment that we have readily available make it difficult to compute a more precise BMI measurement. However, by using computer vision, this can be solved. By using AI on the edge, we can make and analyze measurements without compromising privacy. And by using the Luxonis device, the entire process can also be affordable. Through our desk research and conversations with mentors, we found out that similar solutions have already been released on the market, but ultimately their business models did not succeed. We conducted user interviews with potential customers of different backgrounds, and we found out that while they liked the concept, there were two main concerns: privacy and preciseness of the data. Ultimately, people are worried what can happen to their image if they film themselves in the nude and upload the footage to the cloud. In terms of preciseness, users are not interested in yet another tracking device that will deliver only approximate data. We knew that in order to perform better than what previous products were able to do on the market, we needed to create a solution that guarantees precise measurements while protecting people's privacy. Our device allows for exactly that. With advanced BMI, we're attaching Luxonis devices to mirrors and using the captured depth maps to measure the circumference of certain body parts. By using a custom-trained ML model, we're able to distinguish between body parts, measure their circumference, and track the progress of gaining or losing different types of mass in different parts of the body. No cloud is used, no images are transferred, all data are processed offline on the device and sent via BLE to our custom app on smartphones. Every step in the user journey is private, from unlocking the camera to entering a custom code to confirm the user's identity. So all this sounds nice, but how do we actually make money? Actually, our target customers and partners are fitness studios. They pay a small license fee to use our advanced BMI mirror. We help them to install it and train their staff to get the most out of it. Customers of a fitness studio can use the device and download our app to visualize their data for free. By signing up for a premium account, users get additional features such as tracking over time and even self-reporting their mental health. The studio staff will promote the app by explaining its benefits, and once a user signs up, 50% of the revenue goes to the studio and 50% goes to us. Therefore, motivated studios may use the solution not just as another fitness device, but actually as an additional revenue stream for themselves. Rather than B2C sales, we can focus on selling our solution to more and more studios over time. We also considered working with doctors and clinics to put advanced BMI mirror in health centers, but we realized that there might be some regulations to getting so close to the healthcare setting, and we also know that people don't go to the doctor that often, whereas the gym is a place where people typically go at least once a week, maybe even a few times a week, as opposed to once or twice a year. Last but not least, let me introduce our team. We have Lauri Latu from Finland, currently based in Marseille, PhD student in low latency AI for CERN. We have Mayank Yadav, database and app developer from India, currently based in Berlin. Marvin Murum, computer vision engineer, also based in Berlin, where he's also from, and Johnny Smith from Ireland, based in Berlin, robotics engineer. And myself, Aisha Konate, service and UX designer. I am from France and also from the US, currently based in Paris. In conclusion, for this hackathon, we have developed a privacy-aware way to measure and track body composition using the Luxonis depth camera. We plan to deploy this solution by cooperating with gyms and fitness studios. Over this past weekend, we have developed a working flow for waist measurements, as well as an app that our premium customers can use to track their progress. Thanks for watching.